All right, let's get started then. So if you guys want to follow along, here's the URL for the assignment. Since the one up top is kind of hard to read, hard to see. I'm gonna record this lecture so you guys can have a record of what what the assignment is. Hopefully the software doesn't crash. So, barring that, I'll post something. All right, everyone has it. More time. More time. There's a link to it on the Tewato and assignments. Yeah. All right. So, what I want to do today is to introduce the assignment and kind of give you guys overview of the code and how the whole thing's supposed to function together. There will be things on there that you guys don't have to know yet. Like I don't expect anyone to be able to work with the GitHub just yet until I go over it. Obviously, a lot of you guys have already done stuff with GitHub, so if you want to pull the code and start playing with it, it's really great. You guys aren't also supposed to know how Google Test work, which is the testing framework that we'll be using for this. I'll be going over that. If you know how it works already, or if you want to jump in, like you don't actually need to run any tests. You can just, you don't need to write any tests. You can just run what I have. So that should be relatively self-explanatory. We're going to have plenty of time for this assignment. It's not due until March 6th, until I have a chance to go over everything. And then you guys still have some time to implement it. So if you're totally new, you'll still have time to do everything. But I want to assign it early so you kind of know what you're getting into and can start working on it. Okay, so okay, I'll deal with this later. Okay, so the assignment in itself is the implementation of the Battleship game, where who's not familiar with the game? Okay, what the Battleship game is you have two boards, 10 by 10 boards, and you place your ships. You can kind of read about it here. I have it linked from the assignment. So you create these two boards, you place the ships, and then the other player is giving you coordinates of when they're shooting, of what they're shooting at. And if they hit a ship, you tell them that it's a hit. If they miss, you tell them it's a miss. If they sink a ship, meaning they kind of here hit all the areas of a ship, then you tell them that they sunk the ship. Okay, and then the game goes back and forth in rounds until someone no longer has ships. Okay, so fairly straightforward game, but I think it's a really, really nice model for building a client-server architecture. It's something that we conceptually can understand pretty well, and so it allows us to implement it and sort of deal with the complexity of implementation. Okay. So as far as learning objectives, we'll learn to work with GitHub, CMake, which is a way of making C projects, and Google Test. We'll implement a basic Battleship game, 10 by 10 variation of the game. You can see what the game looks like here. This is like a fancy UI for it, but if you've never played it, give it a try. Okay, so we're going to implement this as a client and server, and I'm going to give you guys a link, or rather, this is already the repository. We're reading the README file in the repository. So the repository gives you client.h and server.h, which are the header files for the client and server programs you will need to implement. I'm also giving you guys runtimes, client_main and server_main. If you just store these as separate processes, that's the game. There's nothing else you need to do to run the game. The only thing that's missing is the functions can implement the functionality in these two files. Okay, so it's sort of a little backwards. Like you don't have to implement the actual game, you just have to implement the functions that implement the game. All right. And I'm giving you guys a suite of tests and tests that you can do. When your implementation passes all the tests, the game will run. Which is kind of cool. All right. So we start by setting up a board. Board is set up as ASCII, a 10 by 10 board like this, and then you have some number of ships on it. So we have different ship types. And so they're represented by different letters. So these are elements on the carrier, and they have to be in a line, either horizontal or vertical. Okay. And you can place these ships anywhere on the board. This makes it easy to explain what they are. Right, totally solid board. So you will need two boards, one for each player, and so we're going to save them as player 1 setup board txt and player 2 setup board txt. Probably there'll be different files for each player, but you can start with the same file to make your testing easier. Also, in the testing, the code I'm providing you runs on a 2x2 board. That makes it a lot easier for you guys to test your programs. When we grade, we'll grade on a bigger board with a different test file. Okay. So you need to implement two types of messages, shot and a result. So shot is when a player makes a shot on another player's board, and result is what the server returns. Let me maybe briefly draw on the board what the architecture looks like as a whole. So you have a server that's running the implementation. The server reads two different files. Player 1 setup board txt and player 2 setup board setup. Okay. Now this is all of this is running on the same machine. Okay. So later on in the course, we will distribute this over a network and do other things to it. But for now, everything runs on a single machine, and communication between clients and servers is going to be done through files. How does this work? So then we have two clients, client 1 and client 2, which are player 1 and player 2. So what the player does is they issue a shot to the server, okay? And the server then looks at, so let's say this is player 1, just to be clear. Okay, so player 1 creates a shot. The server checks the coordinates of the shot, so the shot contains X and Y coordinates, okay? And it checks those coordinates against which board? Player 2's board, right? Because player 1 is shooting at player 2. So we're checking against player 2 board. Based on what's in that board, this shot is going to result in a hit, a miss, or out of bounds. And so you may need to handle that case too. In the fuller implementation of the game, we'll do that later on in the semester. The server should also say if a ship was sunk. We're not doing that in this assignment. There's enough complexity here as it is. Okay, so you're going to have a result, which is either a hit, a miss, or out of bounds. Okay. So how are these communicated? This shot is communicated to the server via file. So the client says player 1 dot shot dot JSON. Okay, so you just write to this file. The server is watching for that file. Okay, when the server creates a result, it will write player one dot results dot. Okay, and then client two does the same thing, shooting at players one's board. Questions? Pretty straightforward, right? Okay. Okay, so those are the shot and result messages. We'll represent these as JSON files and exchange them using local disk storage. Okay, so no networking right now. Let's keep it simple. Okay, program operation. This is just what I explained on the board. Okay. Now to run this program, what you need to do is to start the server. Run server is executable. When you compile your project, that's the executable that compiles. And then you can start two instances or one instance of run client executable. Okay, it should run. Now, when you start these programs right now, basically nothing's going to happen because your client and server implementations do nothing but just return nothing. So that's not very interesting. But you can start running test.cpp. And what's going to happen initially is every single one of your tests is going to fail, right? So then you can look at a set of tests or a single test one by one and say, okay, how do I get this function to pass this test? How do I get the function to pass all the tests for that function, right? And so on and so forth. And you can build up the capability of your program just by passing more and more tests. And this is called test-driven development, and I'll do a lecture on that later on. Okay. The way you'll be graded, I'll skip away that, is purely based on you guys passing the tests. Right, so there's, I think, like 28 tests or something, and you'll get points based on that. I'm not exactly sure how I'm going to assign points to each test. There's 20 points for the assignment, and some tests are more important than others. I'll kind of figure that out a little bit later on. But basically, if you pass all the tests, you get all the points. Real simple. If you're feeling ambitious, I have some bonus features for you guys to implement. My idea of bonus assignments is to give you guys opportunity to stretch, but not to disadvantage people that just want to get through the course. Thank you very much. So the way I do it is bonuses are a not quite a ludicrous amount of work, but a significant amount of work for very little credit, right? So what you get is one bonus point for each of the following features. So server throws an error if both players start with the same player number. So when you start a client, it asks you what player number you are, and if both people enter one, this is not going to work. So we need some way to disambiguate that. Okay. If a ship is sunk, the server sends a different notification. Right. You can do that now for bonus, or we'll do that later in the course for no bonus. So the last one is server detects when a game ends, meaning all the ships or one player are sunk, and then notifies both players as to who has won the game. Okay, so you can get up to 23 points on this assignment if you implement everything. Okay, what you'll submit, I can't think of a better way of doing this. This feels a little kludgy, but someone has a better idea, let me know. So what you'll submit is into the programming assignment folder in D2L, so you can keep track of the submissions. You'll submit one text file, which will just contain a link or a URL to your GitHub repository with your solution. So that's what you want to do. That's great. If you want to implement any bonus features, add another text file telling your TA which bonus features you have implemented. So we can kind of look for that right? So we know to test or to kind of just look for it. If you're implementing these, I will be looking for the implementation as well as tests that evaluate that this thing works. Yeah. You know, he just emailed me last night that he's a TA. I don't even remember his name right now because I just like saw an email as I was leaving the office. So I will let you guys know this soon. Mhm. Any other questions? Yes. Yes, March 6th. And that's on D2L. So D2L is the arbiter of all due dates. There's a schedule that I posted. This is kind of information slash my idea of how this is going to go only. Rough guideline, like go by D2L. That's the only, that's official. Yeah.
Why CMake specific, or does it, or would you prefer that we just use any kind of
So CMake is a great way to make C++ projects. It is the thing to use. And so I will give you guys lectures on linking on make and on CMake. So what CMake does is basically makes a make file, and then make file builds the project. The reason we're using CMake is we're also using a number of packages from GitHub. Specifically, we're using Google Test. We're using something called Serial, like the cereal you eat, but it's for serialization of objects, which is a different spelling. And we're using that, or well, I guess you don't have to, but I would encourage you to use it to read and write JSON files. And then we're using something called DTL, which we're using in testing to verify that the file that your program output matches what you want the file to look like, right? So you have like one JSON file, have another JSON file. Well, how do you know that they're the same? Well, you can do it a number of ways. You can load the JSON, but like I didn't want to do that because then I would have to use serial, which is the thing I want to test. So instead, I'm just comparing it text-wise. So I'm running a diff, just like a GitHub diff kind of thing. And we need those packages. Now, the way those packages are distributed is that they include CMake files. And so if you just import those packages into your repository as submodules and open this up in CLion, which is an IDE that I'll encourage you guys to use, you can just point your top-level CMake to those directories, which will then use the CMakes distributed in those packages, and the whole thing compiles right away. And that's the magic of it. Like I don't understand anything about how Google Test is built internally in terms of their program structure, file structure. I don't need to. I just link to their CMake and it works. Yeah, I think it's cool. So if you have strong feelings, you want to go the other way.
No, you definitely convinced me. It's just,
yeah, it's gonna be good. It's gonna be good. So yeah. Anything else? Okay, so I want to show you what this code looks like, just so we can get kind of started. All right, you guys can't read this at all, which is okay. Yeah. Yes. You want to see if it's still recording? Looks like it. Yeah. Thanks for checking. All right. Yes. Okay. Good question. Okay, so presentation is not going to get any bigger. So we'll do. Yeah? I think that's as good as it's gonna get. It's already kind of ridiculous. I'll close some of these so we can have a better view. Okay. All right. So the way this project is organized is you have your top level project, then you have your source directory, which I'm highlighting. It says SRC, and we have a test directory, which is called test. And I'll go over the files in those. What you see at the top level is two other things. You have your CMake list, which is your top level CMake file. You have player 1 and player 2 setup boards, which then get copied into the runtime directories. I'll talk about that in a second. And you have your README, which is what describes the assignment. Okay, so if we look at, okay, let's start with server. Let's start with server. Okay, so what I'm giving you guys is a .h file for the server. What it contains is fairly detailed comments of what the functions are supposed to do. So in here we have, starting from the top, we have some constants that currently are grayed out because nothing's implemented, so it's not an error. We have a server exception class. You don't need to do anything with it. It's just an exception so we can pass messages. So when you throw an exception, you want to use this exception as opposed to another exception. We have a server. The server contains two setup boards files that it loads, and then it contains a bunch of functions. It has the initialize function, which we need to be separate from the constructor for Google test. I'll show you guys that in a second. And then we have two other functions, which is evaluate shot and process shot. So process shot loads the player shots file, and then calls evaluate shot to determine if it's a hit or a miss, and then process shot writes the result file. And so just two functions of the server that you need to worry about. Well, I guess plus initialize. And then we have client.h, which looks very similar. You have some exceptions here you can use. You have a destructor, which will just remove the action board, which is kind of player's own board. Oh, I guess I didn't mention this. Let me just mention this real quick. So when the result arrives at the player, let's say shot, the player updates its own board, which is player 1 dot action board dot txt. Okay, so that's how you know if you're hitting stuff or missing stuff. I guess that's pretty important, so I understand. Okay, so we initialize by creating our own action board. The destructor here will remove that file when we shut down the program. You have your fire function, which will create the player shot file. You have a check if the result is available. So if there is a result file, if there is one, you can then get it using get result, and then you can update action board using this function based on the result you pass in. And then there's a helper function called render action board, which will convert it from the JSON format to ASCII text format so someone can see it. Okay. Questions? Yeah.
So in between the shot, we'll be rendering the format.
Yep. Yep. Okay. So with that, let me show you guys the client runtime. So you don't need to change anything in this file. It's good as it is. Okay. So the first thing, so you start the Battleship client, and what it's going to ask you to do is to enter the player number. When you have it, oh, this is annoying. The program's gonna ask you to enter the X position, enter the Y position of your fire. Then you're going to do the fire, writing the shot file to a disk, and then you're gonna wait for the result. So when the result is available, or while it's not available, you're going to wait for 2 seconds and then check again. Okay. When the result file is available, you're going to get the result, then print out that a shot at particular coordinates resulted in whatever this returns. If it's out of bounds, you're going to continue the loop, which means start from scratch by entering a new position. Or if it was a hit or a miss, you're going to update the action board and then render the action board to see what has changed. Yep.
Let's say I have a battleship at A2,
Yep.
and my first shot I take is A2 and strike it.
Yep.
What would you like to happen if we put in that same coordinate again?
It's going to result in a hit. It's not gonna. So later on we'll throw errors around that too. Right now it's just going to be like, you hit it again. Yeah. Yeah. There's a whole number of things you can do. I was trying to like make it as simple as possible, but then we'll add extra features to it. Yeah. So if you're passing the tests, you're good. Like that's the official definition of the assignment is the tests, right? And there's smarter ways of doing some things or more features, but you don't have to worry about those for now. Okay, so then we have server.main, which basically runs in a loop, or it initializes based on the player setup boards. It then runs in a loop where it first checks for a shot from player 1, processes that shot, writes the result file, and then does the same thing for player 2, and then continues. Okay, so both of these things will just kind of run forever. You need to kill the processes to exit, just real simple. Okay, so then you can look at server.cpp, which has all the functions in server.h, but they do nothing. This one results no shot file, just so it's so there's not like a crash, but they really just do nothing. So you need to implement those. Similarly, client.c also does nothing, but you have the same functions. And from the .h file, you should figure out what they should be doing. Okay, so then we get to tests, which is in the tests directory on the test.cpp. Okay, so there's a whole bunch of tests, 28 exactly. I'll go over in detail how this works, but for now, the easiest thing to know is that you have these tests, which are classes. So this one is called server initialize. Server just means that we're testing the server functionality and initialize depending on the function that we're testing. These don't arbitrary, but they do correspond to the functions in your program. Right? Okay, so we have a test for server initialize, and the name of the test is correct board size. Okay, and so what I'm checking is that if I initialize the server with a particular board size, which is a constant in one of the header files, okay, that matches the size of the files that I'm passing in. So I'm expecting that this initialization will throw no exception. Okay, wrong board size test. I'm passing in the same board setup files with size of 0. Okay, these are 2x2 files. This should throw an exception, so I'm asserting that there is a throw. There is some exception thrown. Okay. If there's a bad file name, this should also throw some exception. Okay. All right. So for every single other function, like for example, evaluate shot, I'm testing if we can detect a hit, we can detect a miss, we can detect out of bound X, out of bound Y. We can check that if it's a max inbound, this will still result in no throw. We can check if the player number is too low or if the player number is too high. Okay. So for every function, there's a number of tests that it needs to pass. Questions about this? Yeah.
So by player number zero, what you how you say like they pick five, player five.
Yeah, so what I have is max number of flames, a constant amount of the header files, which is set to 2, and then if you add 1, you got amount, which is one of the lessons for testing. You don't want to put an arbitrary number because stuff can change. You want to tag the constants and then keep them at 1 and 5 or whatever. Okay, so let's run this thing. So we're going to run battleship tests. And we're building. This does take a little while. I know you guys can't see it, but it doesn't really matter. We're linking with server, checking dependencies for clients, building the client code. This will take much less time if you guys are redoing this, right? This is just the first time load. Linking to client, okay. Linking with Google Test. Should have ran in the office a little bit faster. Okay, linking with a test file. So building a test file. Okay, and 24 tests failed. All right, but if you have the whole thing implemented and then run it, all the tests pass. Okay, so that's awesome. Let me actually show you how the client and server can run together. But I need to make this a little bit bigger. So we can make console size. Console font. Perfect. Okay, so if I start, so I can go up here and run the server. Okay, so now it's waiting for shot from player 1, who will kind of keep trying to read that file. So the next thing I can do is I can start the client. Okay, and so what it says is enter player number. So we're going to start with 1. Okay, and then I can do a shot. Okay, so I'm going to shoot at 1, 1. Okay, waiting for result. Okay, and then we got the result. Shot at 1, 1, result 1, which is a hit. So we render this as 0, 0, 0 hit. Okay, and now we can enter the next position. But at this point, the server processed shot from player 1, and now it's waiting for a shot from player 2. So you would need to start another client with, initialize it as player 2, or what you can also do is stop this client, run the client again, and then pretend to be player 2. And now you can shoot at, I don't know, 0, 1. And now you can see that was a miss. All right, so that's the assignment in a nutshell. Any questions? Yeah.
So the server is just listening for like a new file to show up in a folder in a directory?
Correct.
And then once it processes and responds, does it delete that file, or is it just listening for like the most recent file, or how does it know
It deletes the file. It should delete the file.
So every time it's running a new file.
Right. So the client makes a shot file. Okay. The server reads the shot file, produces a result file, and then should delete the shot file. And then the client reads the result file, and when it renders the board, it should then delete the result file. Yeah. It's not the most efficient of implementations, but that's sort of on purpose, because in future assignments, what we'll do is you guys will optimize the efficiency of the game state storage using assembly. So it'll be in memory. And then you will also introduce network communication, so we don't have to write files back and forth, and now we can distribute it onto different computers. Yep. Yeah, so you set it up as these, so let me get out of the solutions folder. Okay, you set it up as the player 1 setup board and the player 2 setup board. Those are put into, look like this. So what I have here is a destroyer and a carrier. Obviously they're not full size because it's a small board. And what I also have here is just 1 and 2. These don't mean anything, right? You're only looking for these and C's, so these are misses. But if you're testing stuff, it's nice to know kind of what coordinate you're looking at. So when you're reading, let's say, a character to see what's underneath, you can see like where from this file you're reading. Right? Ultimately, these should be just like underscores for water. Does that make sense? Okay, what doesn't make sense yet? For testing, I'm proposing that you guys develop on a 2x2 board. Right. It's just water. Yeah. Correct. 0, 1. 0, 1. So it's 0 indexed in the top left. I specified this in the assignment. And then you go, so this is 0, 1. So sorry, this is 0, 0. This is 0, 1. Okay, this is 1, 0. Yeah. Yep. So what happens is you have these files here in this sort of the top level source folder. If you look into the make file, okay, so this make file basically includes a source directory and a test directory. So if you look then in the make file of the source directory, what you see is this configured file directive, which copies the board setup files into the CMake build directory. So this directory is where you're actually running stuff from. So your source directory here gets compiled into the source directory here, which includes your run client and server.exe, and includes copies of these setup boards. I'll go over the CMake stuff later, but to answer your question, the setup boards are here, and they're kind of set up before the game starts. Yeah. Other questions? All right, so where are we on time here? So you have 10 minutes. If you guys want to start looking at it, if any questions come up in the next 10 minutes, I'm happy to walk over and try to answer them as best I can. If you're like, none of this makes sense, I'm going to wait for the lectures that explain it all. You're welcome to go about your day. Thanks, guys.